Welcome on Mathematica 567 YouTube channel to today's episode, Rachel, where we're exploring one of the fundamental concepts in mathematics, limits.
Hi everyone! Today, we'll delve into what it means for a function to have a limit as x approaches infinity or minus infinity. Alex, can you start by explaining the basics?
Absolutely. So when we say that a function f(x) has a limit as approaches infinity, it means that as x gets arbitrarily large, the value of f of x gets arbitrarily close to a certain number, known as the limit.
That's right. And this concept is crucial in calculus and other areas of mathematics. But what about limits at negative infinity? How do those work?
Great question. The real number L is a limit of the f of x function. When as x tends to minus infinity and becomes larger and negative, f of x gets closer to L and stays closer.
That's a useful distinction to make. And I think our listeners might be wondering what kind of functions have real limits at infinity or minus infinity. Can you give some examples?
Sure thing. One classic example is the function f of x equals 1 over x, which approaches 0 as x approaches infinity. We can write this as limit as x tends to infinity of 1 over x equals 0.
That's right. And what about the sequence 1 over n? How does that relate to limits at infinity?
Great example. The sequence 1 over n is actually an example of a function with a limit at infinity. As n gets arbitrarily large, 1 over n approaches 0. And we can write this as limit x tends to infinity of 1 over x equals 0.
Now, let's move on to some more advanced topics. What about functions that tend to infinity or minus infinity? How do those work?
Well, when a function tends to infinity at a point, it means that no matter how large the value of x gets, f of x stays larger than any given number.
And what about functions that don't have real limits at infinity or minus infinity? Are there any examples?
Yes, unfortunately, yes. Some functions just don't have real limits as x approaches infinity or minus infinity, but we can still use other mathematical tools to describe their behavior.
Thanks for joining us on today's episode of Math Talk, Alex. It's been a pleasure exploring the world of limits with you.
The pleasure was mine. And don't forget to tune in next time when we'll be discussing more advanced topics in calculus.
That's right, and maybe even some real-life applications of limits.